What's going on, everybody? It's Mr. Gus, and I'm back in the chemistry classroom. Today, we're doing the Evaporation Rate Lab. So what we had here was we discussed the different phase changes. We've done melting, we've done boiling, we've done freezing, we've examined this, and now you've asked some questions around, I wonder how molecular structures dictate or impact how phase changes happen, how hard they are, how easy they are for different chemicals to change phases. So we're studying these types of chemicals that have pretty similar structures. The chemicals we have here today are ethanol, methanol, isopropyl alcohol, water, and I forgot one. The last one is acetone. So we're looking at these structures and building them three-dimensionally, examining their structures, and now we're going to see, hey, which of these phase change easiest or are most difficult to phase change between the liquid and gaseous states. So we discussed evaporation, how it's different than boiling. In class, the definition we came up with was that evaporation is the passive phase change from liquid to gas, whereas boiling is more of a forced phase change, raising something up to its boiling point as opposed to allowing it to just evaporate or transition from the liquid state into the gaseous state kind of naturally at whatever temperature we're at. And today, we're going to be at typical classroom temperature, okay? In class, you design procedures for me, and here's what we came up with as a class. Your procedure was, let's take a drop out of, or 2 drops out of each bottle, place it on my table, and record how long it takes for those chemicals to disappear. We said because things are colorless gases, they'll just disappear to our eyes. We won't be able to see them when the evaporation takes place. So that's what we'll do, okay? In class, I've got ethyl alcohol, I have got acetone, I've got a beaker of just tap water for our water test, I've got isopropyl alcohol, and I have got methyl alcohol, all right? All of these things will evaporate at different rates, and so it's your job to gather some data as I do it. I'm not gathering data here in class. I want you at home while you watch this video to go ahead and record some data. So first things first, let's goggle up. Here we go. All right. I'm going to go right down the list. You can take your data here. I might even put a few drops out at a time so you can kind of simultaneously take data. I might just take observational data as I watch. I think observational data is also a pretty good source of data, even when I am taking quantitative data like time or rate. Okay, here we go. Ethanol is coming up first. Here comes ethanol, sometimes called ethyl alcohol. I'm going to put a drop or 2 drops like we designed in our procedure right here on my table. 1, 2. You can start your timers now. I can smell that. It smells not great. We can just wait here. We're going to wait here for this thing to evaporate. We'll sit here a little while. I'm going to go ahead and actually start the next trial. So hopefully your timer's going on ethyl alcohol or ethanol right now. The next one coming up is methanol or methyl alcohol. Sometimes we just smash that word together. So I'm going to start putting it right next to the ethanol. 1, 2 drops like you all wanted. There we go. So right now I've got ethanol and I've got methanol on the table. I'm going to also put isopropyl alcohol. Isopropyl alcohol is my 3rd chemical. I will go ahead and put that next to, that one spreads out quite a bit. Do you see that? That's pretty interesting observational data. These kind of stay up, clumped up a little bit, and these kind of isopropyl spread out a little bit. That's interesting. I think all 3 are still there. I'm going to go ahead and put water. I don't have a dropper for this, but I'm going to go ahead and just use my finger and use my finger to have drops come off of that. So I'll let this kind of drip off my finger, touch the table. 1, 2 drops of water. We'll let that sit there. And now lastly, let's do some acetone. I'll go ahead and put acetone right next to water. So this is our last one. This is acetone. Smells like fingernail polish remover. I just need to make sure I get enough for some drops. There's 1 drop and there's 2 drops right there, okay? So we can sit here and look at this and kind of say, what's happening here? I haven't really seen the size of any of these things change other than the isopropyl alcohol kind of spreading out. Observational data here. If I look here, not much has changed. Let's see. I'm going to try something out here. Like any experiment, I might try to spread this out a little bit. See what happens, these tails. Ooh, this is my acetone. Acetone is already gone. Acetone has essentially disappeared. Isopropyl alcohol is doing. I can actually smell the acetone in class. So acetone is gone. So my timer should stop for acetone. That was one of the quicker ones. This is my methanol over here. This is my isopropyl alcohol over here. I'm sorry, ethanol and then methanol and then isopropyl water. Well, the methanol is also gone. Isopropyl is getting smaller, but again, it's spread out. So that's a little weird data. That's interesting how it spreads out. And then this is right here. These tails on the ethanol are disappearing, but they're disappearing at a much slower rate than the methanol did. And the isopropyl alcohol is gone also. So acetone went first, and then the methanol streak went, and then the isopropyl streaks went, and then this ethanol streak went, and this water is just still sitting here. But I'm gonna examine this again because I feel like I had more ethanol on the table than I did isopropyl, just because of the way it's spread out. So we're gonna try this. I'm gonna try to streak these like I did before with the dropper. So here's an ethanol streak. And here's an isopropyl alcohol streak. Wow, look at that thing. Again, it just spreads right out. Just streak this guy out. We'll streak this guy out. Oh, wow. If you can see this, where I've streaked the ethanol, it is already evaporating here on both sides. The isopropyl alcohol is spread out, but where I've streaked it is not really evaporating quite yet. But the ethanol is definitely kind of streaking and evaporating. So interesting. Okay, so if I'm looking at this, what I basically can conclude is that there are a couple chemicals. Well, one chemical still hasn't fully evaporated, but the other four have. So we can rank these things, right? Which of these chemicals evaporated first? For some reason, and this is for us to kind of think about using chemical structures and 3D molecule structures to figure out and determine and work our way through this. But for some reason, acetone, these would be the ranks, or the rankings we saw. We saw acetone was the fastest. We can say fastest. Water is the slowest. In fact, water is still on my table. And then these things in the middle. Then it was methanol was number 2, and then ethanol, and then isopropyl alcohol, and water over here was number 5. Okay? So these are my rankings. This is my procedure, and we maybe actually adjusted our procedure while we went through it. Like, this wasn't exactly what we did. So as you think about writing your procedure, edit your procedure. This wasn't perfect, so we need to add a few steps to it. Maybe we add the streaking to it. Maybe you change your procedure altogether using a cotton swab or something. That's up to you as you develop procedures, okay? But that's our data. There was our starting procedure. Go ahead, go over to into your lab notebook now and start researching why you think these things are. Maybe build these models and work through this, okay? But until then, see ya.